All right. Hello, everybody. Welcome back. We're moving on to lesson number 4, and our topic of the day is box and whisker plots. It is actually a type of graph, and it is called a box and whisker plot, or a box plot is another name for it. It's a way to show, especially if you have a whole lot of information, you can kind of show how the data is spread out. That's called the distribution of the data. Um, I will be very honest with you though. It's not a graph that is very common. It's not something you see on the front cover of USA Today, or you're going to see it in a magazine or a newspaper. Really, the few times that you might see it, it would be if you ever do become a statistician, or if you are in a very math heavy profession, you'll see it very often. Or I have seen it in medical journals. So doing if you do any research, or if you're in the medical field whatsoever, you'll probably come across these from time to time regarding different health issues or patient information, that sort of thing. So not as common as say your bar graph or histogram or line graph or circle graph for that matter, but still we can learn a little bit of information from them. So they're not as hard as they might seem, but you do have to know some different terminology. So here are the 5 key terms, and really, of all your data, you're only going to focus on 5 key numbers. It's called your 5 number summary. So you're going to take all of this information, however many pieces of data you have, and really boil it down to 5 important numbers. And those important numbers are what's going to make up your graph. So the 5 numbers have different names. The first one is called the lower extreme, or LE for short, and that is just very simply the lowest number. So you can already tell you probably will want to put your data in order from lowest to highest when you're dealing with a box and whisker plot. Then we have on the other end is the upper extreme, also I abbreviated UE, and that is the highest number. Then we go to the quartiles, and quart is the prefix on that. Quart means 4, like there are 4 quarts in a gallon, so on. These are called quartiles because there are 4 sections to your graph. 5 key numbers will break it up into 4 spaces in between those 5 numbers. The second quartile, which is a Q with a little 2 below it, is just the median of all the data. And you already know how to find the median, so that's pretty easy. It's the middle number. And then we have the first quartile and the third quartile. So if you take all of the numbers to the left of the median, Q2, or the second quartile, if you take that group of numbers, anything below, equal to or below the median, you're going to find the middle number of that group. So you're finding the median of the lower half of your data. And then the third quartile is just the opposite of that. It's the median of the upper half of your data. So you're going to take all of the data to the right of your second quartile, and that'll be what you find the median of for the third quartile. And then we have what's called the interquartile range, and that is just that's going to be the box. That's Q3 minus Q1. I'm going to say this is the box of your box and whisker plot. So it's going to be the highest number of your box minus the lowest number of your box. So remember the term range we talked about before was your highest number minus your lowest number, and that would be the same case for this. But if we're finding the interquartile range, interquartile means between the quartiles. So your highest quartile minus your lowest quartile. And then outliers, we already know, are extreme values. So either extremely low or extremely high. Either way. All right, so now the only way you're really going to get anything out of this is if we do this. So let's look at an example so you can kind of start to get some visuals of what we have here. So the example says the data given shows the number of points scored per game by a member of the basketball team. So here's our data. So the first thing we want to do to find our 5 number summary is let's put these in order. So let's take a quick minute here. There's a 7, there's an 8, see, 10, 12, 13 are the next ones I see. 15 and 15. So put 2 of those. We have an 18. We have a 20. Boom, boom. 23 and 39. Oops, 39, not 29. My bad. 39. And then it says create a box and whisker plot for the data provided. Fill in the blanks with the appropriate numbers. So very conveniently, I have given you all of your 5 key numbers. We're just going to fill in the blanks. And then the number line. Your graph actually goes above a number line. So if you remember back to when we did linear inequalities, where you would do your open or closed circle and then draw an arrow to the right, it's kind of like that, but it's a data graph. But you're essentially doing a similar idea by using the number line and including what numbers represent your data. So lower extreme, I always put this one first because, well, they're the easiest to figure out. Lower extreme, remember that's our least number, our smallest number, which is 7. Our upper extreme is 39, the highest number. Then we go to Q2. Remember, this is just the same as the median of all the data. And there's a reason why I do them in this order. It's very, very easy, a little bit harder, and this takes the most thought, and it depends on what this guy is. So let's find the median, the middle number. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, nice and odd, which is good. So that means the sixth number, 1, 2, 3, 4, 5. Oop, miscounted, 3, 4, 5, 6. So this 15 right here should be our median. We have 5 numbers to the left, 5 numbers to the right, so that's got to be our middle number. So our second quartile is 15. That's the median of all the data. Now, Q1 is another median. It's just the median of all the numbers to the left. So all the numbers that are smaller than our second quartile. So really everything in this rectangle here. And nice enough, there are 5 numbers here. So the median of this group will be the middle number. 10, 10, 10. Wrote a song about it. Maybe I'll sing you the whole song later on. So Q1, boom, 10. Now Q3 is the median of the upper values. So all of the data to the right of our median, which is everything in this rectangle. Again, there are 5 values. What is our middle number? It is 20, 20, 20. There you go. Similar to the 10 song. So those are our 5 key numbers. Boom, done. Now all we have to do is make our graph. So remember, our graph has to start at 7 and go all the way up to 39. So you need to keep that in mind when you're marking off your numbers on your number line, because that's all this is. It's just a number line. So whatever you choose for this space to be right here, you've got to make that the same amount each time. So I think I'm going to make mine 2s. I'm going to start with 6. Why? Because I can. This right here just has to be included. And I think if we go up by 2s, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Oh yeah, that'll fit. So 8, 10, 12, 14, 16, 18. I'm going to start skipping. Whoops, that's 18. 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42. Now you realize even though I was skipping labeling, each of these units right here, the space between 2 marks is still 2 units. I just didn't mark. Maybe I should just go ahead and do it. Just to avoid confusion, I won't be so lazy. 28, 30, 32, 36, 38, and 40. Okay, that's not so bad. All right, now go back to each of your values, 7, and above that number on the number line, we're just going to put a little dot. So that's about where 7 would be. 39 is going to be between 38 and 40. 15 is going to be right here. And 10 down here. And then 20, oop, right there. Now we make our box and whisker plot. At your lower extreme, this is our first quartile. This point was our second quartile. This point was our third quartile. This was our lower extreme. And this is our upper extreme. We're going to draw a line to connect the lower extreme to the first quartile. We're going to draw a little vertical line about yay big from quartile 1. We're going to draw another little vertical line about yay big at quartile 2, and then the last one at quartile 3. Then we're going to connect the tops of all those little lines that are about yay big. And now I think you can see where the box and whisker plot came from. Oh yeah, right there, right there. And then we connect Q3 with a line, whoops, straight line, not so curvy, to our upper extreme. And there you have the whiskers. Ooh, look at them, just like a little kitty cat. Whisker. That right there is another whisker, Mr. Whiskers. And then this, shaboom, is your box. Box and whisker plot. That is exactly what a box and whisker plot looks like. And you're done. Ta-da! All right, so now what does all this mean? Well, if you go to the next page, we'll kind of come back to that. When you look at your graph, remember we called those quartiles, first quartile, second quartile, third quartile? Well, if you look at the actual graph and look at the physical aspects of it, you actually have 4 sections. You had 5 key numbers, LE, Q1, Q2, Q3, and UE, but there are 4 sections. From here to here is one section. From here to here is another section. From here to here is a third section, and then from here to here is the 4th section. So there are 4 sections or pieces which make up our quartiles. So 3 quartiles break it up. So when you go back and look, first quartile below this little whisker right here, up from the lower extreme up to the first quartile, that represents 1/4 of the graph, or 25% of your data. So that graph should tell me that when I look at Q1, if I didn't know all the data, I could make a very reasonable estimate or guess that 25% of my data is below 10 in this. So you have 2 numbers that are below 10 out of a total of 11. 2 out of 11. Now that might not be exactly 25%, and it's not. It's a little under 20%. It's about 18 or 19%. But it is a ballpark, an estimate. Sometimes it is dead on, and sometimes it's just very close. So about 18 or 19% is not that far off. When I go to Q2, I have 2 sections to the left and 2 sections to the right of Q2. So that means if this is 25% of the data, that means this is another 25% of the data. So Q2 represents the 50% of the data that separates the bottom 50% from the top 50%. So that tells me that approximately 50% of my data should be less than the second quartile. All right, and third, what percent of the data will fall below the third quartile? Whoops, wrong way, wrong way. Well, again, there are 1, 2, 3 sections below or to the left Q3. Each of those represents a fourth or 25%. So that means that 75% of the data, oops, don't mean that. You can take out those percent signs, extra. 75% of the data falls below Q3. Again, it's not exact, but it just gives you an idea. And then the box, that actually contains the middle 50% of the data. So if we go back and take a look, the middle 50% falls between 10 and 20. And again, not exact, but close. So between 10 and 20, that's everything in here. So that's 1, 2, 3, 4, 5. 5 out of 11, that's about 45, 46%. So that's pretty darn close. All right, moving on. That's kind of a description of how you would interpret a box and whisker plot. Now, some of the advantages, they're not hugely popular, like I mentioned before, not very common. You definitely have to know what you're talking about to read a box and whisker plot. Most, bar graphs are pretty easy. But a box and whisker plot has a few strengths, some of which are it displays the spread of the data, which we've talked about before. It's how it's distributed. So how far apart are these numbers? We have our low number, we have our high number, and then what's the breakdown in the middle? It gives you an idea of the data symmetry. If you have a very symmetrical box and whisker plot, then that means your data is very symmetrical, meaning kind of evenly spaced out. There are no major um, outliers or weird values in that group. It's pretty symmetrical across. It will show outliers more so than any other type of graph. And the way you'll be able to tell that is by looking at the whiskers. So look at our whiskers here. When I was talking about symmetry before, this is not symmetrical. If I tried to split this physically in half, the two halves would not be mirror images of each other. But if you look, the the whisker on the left and then the two sections of the box are fairly similar in length. So that means all these numbers down here are pretty well close together. But then you go all the way down here to the upper extreme, which is 39, and that whisker being so long, it makes you look like you have a lopsided cat. One whisker is really short, and then one whisker is really, really long on one side. It just doesn't look right. So that tells me I might have an outlier, that this 39 is probably an outlier, um, and that can skew my data. So that's a really good one, good interpretation you get from box and whisker plots. All right, and then last, your data sets can quickly be compared by graphing two box plots on the same graph. So you can do one and then put another one right above it, and then you can compare the two. And you can display large numbers of observations easily, meaning you can have a ton of data, 1,000 pieces of data, and the graph comes down to 5 key numbers. So there you have it. Okay, so why don't we take the next, we've got 2 more examples here. Everything's all set up for you. We just need to go ahead and fill in our data and then make the graph. So why don't you pause here and see if you can't start off this first one. I will give you a hint. Put your numbers in order and then check back. If you're really stumped, uh, do as much as you can, fill in as much as you can, and then come back and play through the example with me. Okay, I've got my numbers in order, and I found my lower extreme and upper extreme, which was pretty straightforward. Now, when it comes to my median, this is where it gets a little bit dicey. I have 12 numbers here because there's 12 classes. So I have 2 numbers in the middle, 19 and 21. So I have to take the average of those 2, which would be 20. So my second quartile is actually not even a data value in the list. It's 20. So that's going to affect Q1 and Q3. Remember I said to find the lower or the first quartile, you take all the data to the left of the median. Well, the median sits right here, so all of the data to the left would include 19 and down. So there's 1, 2, 3, 4, 5, 6. The two middle numbers are 15 and 16, which means I have to take the average of those or take the number halfway between, which is 15 and a half. Same thing for my third quartile. I've got 6 numbers. Remember, 20 is not included in this, but 21 is. So we have 6 numbers. Middle number is going to be halfway between 23 and 26, or the average of those two, which should be 24.5. Now, why don't you go ahead and fill in your numbers. Let's go with a scale of 2. So maybe start down here with 10 and count by 2s. So go ahead and do that and see if you can make your box and whisker plot like we did in the last example, and then check back. So your graph should look very much like mine. 10 and 37 are the ends of our whiskers. Q1 is at 15 and a half, so you're going to be closer to the 16 than you are the 14, because 15 is going to be right here in the middle. The second quartile was 20, and then your third quartile was 24.5, so just a little bit past the 24. So in this case, if you look at your graph, you can see most of the graph is pretty symmetrical. This whisker right here might tell me that I have an outlier. 37 is a little bit different than the rest, so I would call 37 an outlier in this case. If it was much longer, then for sure we'd have a different outlier. But if it was just a little bit closer, it would be a very symmetrical graph, meaning all your data is pretty evenly distributed and pretty close together too. All right, so I'm going to let you do this last one on your own and then come back in just a minute and get the answer. See ya. So I put my lower extreme, upper extreme in here. My second quartile was actually not a data value since there's 8 numbers. I'm going to have to take the average of the 2 in the middle. So it'd be 74 because it's halfway between 73 and 75. Same thing with quartile 1 and quartile 3. You had 4 numbers to the left and 4 numbers to the right of your median. So you have to take the average of the 2 in the middle, which is 68.5, and then the average of the 2 in the middle over here, which is 78. So then I went ahead and put my points. Got a little sloppy down here. That should be a nice straight line. I had 67. I have my 85. I put a little vertical line on 68.5, little vertical line on 74, little vertical line on 78, connected my box, and then connected my whiskers. And there you have it. Now in this one, it looks like your data is fairly spread out. These two are the bigger ones, and then you have a small gap down here, so which kind of leads you to believe that um, you have more data that's smaller. Um, but overall, I don't know that I would say that there's an outlier. It looks like there could be an outlier because that whisker is so long, but when you go back and look at your data, if you have that luxury of being given the data, you can see that 85 doesn't really stick out like a sore thumb because 81 is right there, and that's pretty close, and 75 isn't too far off. So this is a fairly well distributed group of data. So that's all there is to it. That's what a box and whisker plot looks like, and that's how you make one. So if you can do that and interpret a little bit about a box and whisker plot, you will be in great shape. So now it's time for you to practice on your own. That is the assignment for lesson 4. And I will see you next time. Peace out.